This is number 15 from on your final review from chapter 3. So this was dealing with exponential equations and logarithms and solving all of that. And this is when they got a little bit more complicated. So if you look at this, this is actually a quadratic in disguise. So I know I can rewrite this term. Well, when I have two things multiplied in my exponent, that means I can split it up as 3 to the x, and then it'll be squared. And then this, think about, well, when you add exponents, when do we add exponents? Well, when we're multiplying two things with the same base, we add their exponents. Remember, that's our rule. So that's equal to x to the fifth. So I can re-split this back up and rewrite it as 3 to the first times 3 to the x. Because I wanted a 3 to the x to see that, oh, I do have a quadratic in disguise. Because here's my variable. And then it's minus 4. And a lot of you don't like looking at that 3 to the x. So you can do something called U substitution, or replacing it. Or just realize this is your x value. All of this instead of x is what you're going to use. So we just factor like we normally would. We have to think what multiplies up to negative 4 but adds up to positive 3 because that's my lead coefficient. Okay, so I'm going to set up my parentheses. Now the only thing is, instead of x, remember what I'm squaring and what my variable actually is 3 to the x. So that goes in front. Okay, because this is exactly like x squared plus 3x minus 4. But instead of x, it's actually 3 to the x. So again, I ask myself what multiplies up to negative 4, but adds up to 3. So that's a positive 4 and a negative 1. And that's still equal to 0. And then I set it like I normally would. So I'd get, instead of x, it's 3 to the x equals negative 4. And then 3 to the x equals 1. Now, I want to solve for x, but x is in my exponent. So we have to think, is there a way we can bring that exponent down so it's not an exponent anymore? And the answer is to use logs. So what you're actually going to do is take the log of both sides, or you could take natural log if you wanted. They'd do the same thing. So log and log. And we do the same thing for over here. So I'd get log of 3 to the x equals log of 1. Now the problem becomes, okay, log negative 4. Remember, we cannot take logs of a negative number. So this is impossible. Also, 3 to no power will give you a negative number. It's impossible. Because if you throw in a negative in here, it just makes it a fraction. Like 3 to the negative 4th is going to be 1 over 3 to the 4th. So there's no way to get negative numbers. So this does not work. So then I come over here. Now, you're probably thinking, why did this help us? Remember, we have a property that says we can bring the exponent out and multiply it out front. So I have x times log of 3 equals log of 1. And then I want to solve for x, so I'm going to divide by log 3, divide by log 3. Okay, so then I get x equals, oh, I am like moving my paper way too much. I am sorry. X equals log of 1 divided by log of 3. And that is your exact answer, but actually you should know what log of 1 is, because if you remember what this is actually asking you, our base of just regular log is 10, so this is asking 10 to what power gives me 1? Well, anything to the 0 power always gives me 1, so I actually know log 1 is actually equal to 0, and I don't know what log 3 is, but that's okay, because 0 divided by anything is 0. So my answer is 0. And then you could always plug that back in to solve. So if you wanted to, you could go 3 times 2. Or I said that wrong. 3 to the 2 times x plus 3 to the x plus 1, but x was 0. Oh my gosh, I can't write today. Minus 4 equals 0. Well, 2 times 0 is 0. 3 to the 0 is 1. Plus 0 plus 1 is 1. 3 to the first is 3. And then my minus 4 equals 0. 1 plus 3 is 4. Minus 4 is 0. 0 equals 0. That worked. So your answer is x equals 0. So to recap quickly, all you had to realize was this is actually one of those quadratics in disguise. We just have to remember how we can rewrite this. So this can be rewritten as 3 to the x squared. And then because of our addition property of exponents, I knew I could actually split that back up, because when we're adding exponents, that's when we had the bases the same and we're multiplying. So it's just going backwards from this step to this step. And there's how you do number 3, or number 15. Where's the step?